Hello, my name's Robert. Welcome back to my workshop. Just a short video this week. I've spent the last couple of weeks restoring a vintage pillar drill. I didn't video all of the restoration since a lot of it involved nothing more than cleaning grease out with solvent, wire wheeling paint off and spraying paint onto it. However, it's got quite an interesting little mechanism, at least I thought so. So I thought I'd share that with you. So let's get on with it. And here it is. It's a little Ixion brand drill press. This thing's a vintage machine for sure. It lived in my parents' shed for as long as I can remember, and I believe it was my step-grandfather's before then. So that probably makes this machine something like about 80 years old. When I got hold of this, the insides here were caked in grease, despite the fact that there's an oil point on the top. I wasn't sure exactly how it works, but I found some information on a woodworker website which told me a little bit more about it, about how the feed mechanism works, which I thought was quite interesting and quite novel. So what I found interesting about this little pillar drill was the way the feed mechanism operates and how it automatically regulates the downward pressure on the drill. So the way it functions, the handle here turns a set of gears inside which turn a little bevel gear which is keyed onto the spindle. That causes the spindle to rotate, but the back end of the spindle has what I believe is a 10 TPI thread which goes inside a tube on which the flywheel rotates. So this means that if I hold the flywheel still, as you rotate the handle, the chuck starts to feed down. Now, if you hold the handle still and you rotate the flywheel in the same direction, it brings the chuck back up. There's a little plunger inside this housing up here which bears on the tube that the flywheel sits on, and the way the thing is arranged, that as you turn the handle, eventually the drill bit will produce enough resistance that forces up on the screw and causes the flywheel to rotate. The more resistance on this tube, the harder the drill has to press on the workpiece before the flywheel starts to rotate. Once the flywheel is up to the same speed as the chuck ceases to feed down anymore. So eventually what will happen is the flywheel will rotate just slower than the chuck, and the chuck will start to slowly drill its way through the workpiece. It has the obligatory, should we say, evidence of use in the table, which is a bit of a shame, but that's just going to stay there. And this is the view of the top of the flywheel. I presume oil is supposed to go in there, not the grease that the thing was packed with. So I'll take off the front cover and show you it inside and how it works. So here's a closer up shot of it. We have two positions we can fit the handle to. The top one has a gear ratio which multiplies the speed of the handle up. The lower one is used for your higher torque setting. There's a little idler cog in the middle, which means that the handle rotates clockwise to feed down in both cases. A bevel gear here transmits the power onto the bevel gear, which has a sliding key, so that the spindle with its keyway all the way down is driven just by that key. Up here you can see this 10 TPI thread. This is threaded up into the tube up here on which the flywheel rotates, or is attached to, and a pair of thrust bearings up here support the flywheel. When I rotate this handle, you can see that we start to feed this screw down. It's actually bottoming out at the moment, which is how it's managing to drive the flywheel around. And if we rotate backwards, the chuck will retract. There's a lever on the back here which enables the whole drill to be raised or lowered depending on the length of the drill bit you want to put in here. So I guess the only other thing to do is to demonstrate it working. Drill press vise, piece of scrap aluminium. So I've left the front cover off so you can actually see the guts of it working while I'm demonstrating it. Obviously normally the front cover will be fitted all the time. Just put that in there to hold it, and off we go. There we are through. So here we are set up to drill a piece of steel. The presence of the hole suggests that this is the second attempt. The first attempt, somebody didn't press go on the camera. There we are. That was easy. Hopefully you found that interesting. Just a short clip. This is probably more sentimental value than practical application in the workshop, but I've restored it and it's a nice thing to have. So with that, thanks for watching.